Okay, our last lesson in Chapter 3 is Section 3.7, Slopes of Parallel and Perpendicular Lines. So if you recall, parallel lines have the same slope. And looking at our graph to the right, I can find the slope of line L. So I'm going to start at the bottom point and go to the top point. And I went up 1, 2, 3, 4, and over to the right 1, 2, 3. So my slope is 4 over 3. Same idea for line M. If I start the bottom point and go up 1, 2, 3, 4, and over to the right 1, 2, 3, my slope is 4 over 3. So lines L and M have the same slope, and I can say line L is parallel to line M. In our examples, if we want to check for parallel lines, recall our slope formula. Remember, change in y over change in x. We can use this formula to find our slopes and then compare our slopes of our two lines. So in number 1, line A goes through the point P at 0, 3 and Q at -2, 5. Line B goes through the point R, 0, -7 and S, 3, -10. And we want to know, are the lines parallel? So first, let's find the slope of line A. So I'm just going to say M sub A, and I will do change in y over change in x. I get 2 over -2, which reduces to -1. Then for my slope of line B, again, change in y. Now here, -10 minus -7 will become a +7 over change in x. So I get -3 over 3 or -1. So yes, my two lines are parallel. Same idea, number 2. We have line E goes through the point J, -4, 1, and K, 2, 4. Line F goes through the point L, 1, 5, and M, 5, 3. So first, let's find the slope of line E. So change in y over change in x. So 3 over 6, which reduces to 1/2. And then slope of line F, change in y over change in x, which reduces to a -1/2. And no, these lines are not parallel. Remember, the slopes have to be exactly the same. So that means same number and same sign. Okay, number 3, we want to determine if these two lines are parallel. Y equals 1/2 x plus 5, and 2x plus 4 equals 9. So when our lines are in slope-intercept form, remember whatever comes in front of the x is our slope. So the first line, I can identify that my slope is 1/2. But in my second line, I need to first get the equation in slope-intercept form. So if I solve for y, so subtract 2x, and then remember, if you cannot combine like terms, just write them next to each other. And then divide everything by 4. I get y equals -2 over 4x, and I'm just going to leave that as 9 over 4. We're not concerned about the y-intercept, we're concerned about the slope. And then I can reduce my slope here, so I have y equals -1/2 x plus 9/4. So my slope is -1/2. So slope 1/2, slope -1/2. No, these two lines are not parallel. Same idea number 4. We have y equals -1/2 x plus 5, and 2x plus 4y equals 20. So in the first line, my slope is -1/2. And then in the second one, I need to solve for y. So subtract 2x. Divide each term by 4. And I'm going to reduce -2 over 4 is -1/2. 20 divided by 4 is 5. And now I can identify my slopes -1/2. So I see that I have exactly the same slope. So yes, these two lines are parallel. Okay, two more examples dealing with parallel lines, and then we'll look at perpendicular. So in 5, we want to write an equation for the line parallel to 6x plus 3y equals 12, and it goes through the point 5, 7. So recall from last lesson, point slope form, y minus y sub 1 equals m times x minus x sub 1. We are going to need to use this formula for numbers 5 and 6. Okay, so over on the side, I'm going to label what I know. I already know that my x1 is 5, my y1 is 7. I do not know my slope yet. So in my equation here, I need to solve for y. So just like we did in the last problems, I want to get y by itself. Divide everything by 3. So y equals negative 2x plus 4. And if we're writing an equation of a line that's parallel, I will use the same slope. So here's my information. Using the point slope formula, I'll take y minus 7 equals negative 2 times x minus 5, and then simplify and solve for y. So my final answer, y equals negative 2x plus 17. So this line is parallel to my original line, and it goes through the point 5, 7. Okay, and in number 6, same idea here. We want to write an equation line parallel to 4x minus 6y equals 3, and goes through the point negative 1, 3. So let's identify what we know. Our x1 will be negative 1, y1 will be 3, and we have to solve for y to determine what our slope will be. Oops, this should be a y. There we go. Divide everything by negative 6. And I'm going to reduce negative 4 over negative 6 is a positive 2/3. And 3 divided by negative 6 is negative 0.5 or negative 1/2. So the slope I'm going to use is 2/3. Alright, so using our point slope form, y minus 3 equals 2/3 times x minus negative 1, so become a plus 1, and then simplify. So y minus 3 equals 2/3 x plus 2/3. Add 3 to both sides, so it's the same as adding 9/3. So y equals 2/3 x plus 11/3. And since we're not going to be graphing this, you can leave your y-intercept like that, or you could write it as a mixed number. Alright, now we're ready to look at perpendicular lines. So remember, perpendicular lines have opposite reciprocal slopes. The product of their slopes is negative 1. So if I want to find the slope of the line x, I'll start at the bottom point, and I count up 1 and go right 2, so my slope is 1/2. Then if I want to find the slope of y, I'm going to start I'll start the top point, go down 2, right 1, my slope's negative 2 over 1, or negative 2. So we see that 1/2 and negative 2 are opposite reciprocals. One is positive, one is negative, and 1/2 and 2 are reciprocals. So we can say that line x is perpendicular to line y. Okay, if we're going to check for perpendicular lines, that means we're going to compare their slopes. So again, our slope formula, change in y over change in x. In number 7, we know line G contains the points M at 0, 8 and N 4, negative 6. Line H contains the points P at negative 2, 9 and Q 5, 7. So if I want to find the slope of line G, remember, change in y over change in x. negative 14 over 4, and make sure we reduce that to negative 7/2. Also remember, slope is always an improper fraction, never a decimal or a mixed number. And find the slope of line H. We get a negative 2 over 7. So yes, 7/2 and 2/7 are reciprocals of one another. However, they have the same sign. They're both negative. So therefore, these two lines are not perpendicular. So it's a no. All right, same idea number 8. Let's find the slope of line T, which contains the points negative 2, 3, and 6, negative 3. We get negative 6 over 8, or negative 3/4. Then find the slope of line B, which contains the points negative 3, negative 2, and 0, 2. We get a positive 4/3. So 3/4 and 4/3 are reciprocals of one another, and our two slopes have different signs. One's positive, one's negative. So yes, these two lines are perpendicular. All right, now we're going to determine if the lines are perpendicular or not. So in number 9, we have y equals 6x minus 1 and y equals negative 1/6 plus 3. These are both in slope-intercept form, so I can identify my slopes quite easily. In the first one, my slope is 6, and in the second line, my slope's negative 1/6. So yes, these two lines are perpendicular. In number 10, we have y equals negative x minus 7, and y minus x equals 20. So first line, my slope's negative 1. And the second one, I need to solve for y. So we can do that by adding x to both sides. And then I can identify my slope is a positive 1. So negative 1 and 1 are opposite reciprocals of one another. So again, yes, these two lines are also perpendicular. All right, here are our last two examples for perpendicular lines. We are going to write the equation of the line perpendicular to y equals 1/2 x minus 9 and through the point 1, 7. So again, keep in mind our point slope form. I'll write that at the top. Identifying what we know. So here, if my slope is 1/2 and I want to write the equation line perpendicular, I need to change the sign. So I'm going to have a negative and flip 1/2, I get 2. Opposite reciprocal of 1/2 is a negative 2. Then my x1 is 1, my y1 is 7. All right, using point slope form, we have y minus 7 equals negative 2 times x minus 1. And then we will simplify and solve for y. I get y equals negative 2x plus 9. And finally, number 12, we want to write the equation line perpendicular to 5y minus x equals 10 and through the point 15, negative 4. So first, let's solve for y in our equation. So let's add x and divide everything by 5. And I'm going to write x over 5. That's the same as 1/5 x. And then 10 divided by 5 is 2. So if I want to write the equation of the line that's perpendicular, if my slope here is 1/5, I need to change the sign. So I will have a negative and then flip it. So take the reciprocal of a negative 5. x1 is 15, y1 is negative 4. So using point slope form, this becomes y plus 4 equals negative 5 times x minus 15. And then simplify and solve for y. So our final answer is y equals negative 5x plus 71. Good thing we are not graphing these.